Go ahead.
Okay, we just popped out the ruler.
Mm-hmm.
We're going to put on our pressure device. Now, it takes a little bit more of a stretch. That's okay. Now, we don't use the lead plain oil. We have calibrated lines right here. But before we do anything, right here, we're going to run the line through here. So that means I've got to take this weight off, run the line through there. Come on. And attach the lead on there. Oh, sorry. Yeah. So when we put this in the water, we put the lead down first, and then as the beads pass the space, hopefully the camera will be recording them and we'll know how deep it is. You'll see, I hope. I'm just dropping the weight over the side, feeding the line through. On the bottom there now. Okay, put it over. Oh, balance out. I don't like the way it's sort of sitting right now. Camera's going.
Yep, camera is going.
Okay.
How many feet?
I don't know. Oh. Won't know until we get it on the camera.
Yeah.
Check the video.
Well, you can see it right from the beginning. You know how like when we had that down there?
Yeah.
Before we dropped it into the water, you can see, because that would be the depth, the maximum depth anyway, right? And that would be just...
Yeah, we have, no, that would be
Oh,
basically
no,
0, and then it counts down the other way.
Oh, okay, I see.
So what's next, Peter, now? This was a success.
We hope it's a success. We'll have to look at the GoPro footage, see if it works, and we may have to refine the volume container, the glass. It was a little heavy, so it went down tilted. So I don't know if that's going to influence the math or not. We'll have to see. I'll have to reinforce the gluing on the beads as well. But I think it's going to be good enough for students. I mean, it's not rocket science, but it'll do.
So this is going to be used for your ACE course?
For the ACE course, and for probably your invert course.
Yeah.
So.
Great.
Excellent. So let's look at the apparatus that we're using in this experiment. You'll see it's an inverted jar, similar to this, and you'll see that there's a tube with a line passing through it. Okay, this tube with the line passing through it is connected to a weight that goes to the bottom, and in that tube, on that line, are a series of beads placed every meter apart. So what we're going to see is those beads passing through that little slot as we lower this device into the water. And before we lower it in, notice that when we run the beads through here, the very last one, when this is basically we're on the surface of the water, the beads have got here a blue and 2 reds. The blue represents V for 5, and the red represents I, Roman numeral 1. So VII is 7. So that bead there is 7 meters above the weight, which is sitting on the bottom of the ocean. I've taken away half a meter, so we're going to say that the water, the surface of the water, is 6.5 meters above the bottom. When we lower this down to the bottom, you can see we're sitting right on the bottom here because you can see the debris around the edges here. You'll notice that that purple there indicates the bottom bead. That's at 0 meters. So we're now 6.5 meters below the surface of the water. We've got 2 levels because this is crooked. Ordinarily this would be very frustrating, but we're clever people. We can average these 2 numbers. We read the scale off the back and see that's 12.5 centimeters. The front, the water level, is at 9.1 centimeters. We average that out, and lo and behold, we get 10.8 centimeters. Okay, that's the height of water when we're sitting on the bottom. So the air in here is being compressed by that much. As we start raising the device up, notice we're now at 2 meters off the bottom. And being 2 meters off the bottom, that means we're 4.5 meters from the top, from the surface of the water. Our 2 levels, 10 centimeters, 6.5 centimeters. There's our indicator of 2 meters, and the average is going to be 8.25 centimeters. Okay? So we'll raise it up even more. And at 3, notice we've got 3 blurry beads here, Roman numeral 3, so we're 3.5 meters below the surface. 8.5, 4.5 for the 2 levels. We average them out. We average them out, and here we have 3 meters, 3.5 meters from the surface. We have an average of 6 centimeters. So we'll continue to raise it up. We're now 4 meters from the bottom. This number is going up because we're getting further away from the bottom, but we're only 2.5 meters from the surface. There are the differential, 6.8 and 2.9 centimeters. That's going to average out to 4.8 centimeters. That's at 4 meters from the bottom. If we take this data that we've obtained and graph it on a graph like this, where we put along the x-axis the depth of the water, this is the ocean depth. Now remember, it's 6.5 meters deep, so we'll end up out here somewhere, 6.5 meters deep. And if we plot against that on the vertical axis the height of the water column in the container, we get to indicate with little marks on the graph, stars. There's our first point. When the container was on the surface, we had 28 centimeters of air in that vial. When we lowered this down 2.5 meters into the water, we had a reading of 23.8 centimeters. So we continued to lower it in, lower it down, lower our device down, and at 3.5 meters, there's 3.5 meters, we had a depth of 22 centimeters. At 4.5 meters, we have a depth of 19.75 meters. And then, when we hit the bottom, zero, it was zero on the bottom, we're now 6.5 meters down, we have a reading of 17.2, right there, 17.2 centimeters. Now, if we were to take a line and join all these points, we would see something like that. At this point, the volume of the air has gone from 28 centimeters, or the height of the air has gone from 28 centimeters down to 14 centimeters. We have, in fact, doubled the atmospheric pressure. So when we get down to 8 meters, right here, when we get down to 8 meters, we have 2 atmospheres of pressure. Now, I'm told that we can calculate pressure. My good friend Irfan told me that the formula for pressure is P is equal to rho, G for gravity, H, a height of the column of air, plus atmospheric pressure on the surface, at 0 on the surface. Apparently, when you do this, you can calculate exactly what the pressure for the water is. Here's a little question for you. That, whether you recognize it or not, is the Titanic. The Titanic is sitting on the bottom at 3,800 meters, 3.8 kilometers. What would happen if on board the Titanic, amongst all of the dishes, we've got our little device right here? What would the volume of the air in that cylinder be? There's a little problem for you. Okay, with that I'll leave you and let you do a little bit of calculating, see if you can figure out exactly what we'd have. And think about the consequences of that sort of pressure on organisms living at the bottom of the ocean. Okay, talk to you later.